Okay, so I'm here. Okay, so we were talking about the electric dipole, a system of two equal and opposite point charges separated by a very small distance is called as electric dipole. So 2 point charges, the condition is point charges, it should be point charges and they should be separated by a very small distance. They should be separated by a small distance and it is called as the electric dipole. So here we can see there are 2 charges. This is plus Q charge and this is minus Q charge. Both are having equal magnitude and they are separated by a very small separation, very small distance. So this kind of system constitutes an electric dipole. So this is an electric dipole. So here we can see in this diagram, this is plus Q charge and this is minus Q charge, and these 2 charges, these are point charges, they are separated by a very small separation, very small distance. So the condition is these charges must be point charges and they should be separated by some distance, equal and opposite point charges, right? So this system of charges which are separated by small distance is called as the electric dipole. So this diagram shows electric dipole. So we can see here this system of equal and opposite point charges, they create electric field in the surrounding medium. They also produce the potential because they are charges. So because of that there will be some electric potential, there can be some electric field. So that we will determine that we are going to derive the expression for that later on. So this system is called as the electric dipole, which already you are familiar with. Now we define for this electric dipole, we define a very important quantity. We call that is electric dipole moment, right? So this electric dipole moment, it is the product of the magnitude of the either charge. Any of the charge you take in its magnitude, right? So product of the magnitude of either charge and multiplied by the separation between the charges. So that is that quantity. So I have this system of charges which is constituting the electric dipole. This is the center of these 2 charges. From here to here, center to this charge is at a distance d, and from this center of this dipole, this charge minus Q is at a distance d. So separation between these 2 charges is 2d. Right? So we define a very important quantity, that is we characterize this dipole with a very important quantity we call dipole moment. Right? So this dipole moment is defined as the product of the magnitude of the either charge multiplied by the whatever is the separation between the 2 charges. Sometimes you will find in some books this quantity separation between these 2 charges is denoted by small d. Okay? So d से उसको denote करते हैं ये. So d is the separation. If we take d as a separation, then from center to here we have to take d by 2, and then this quantity accordingly will change. That will come as a d, qd. So accordingly different books may find this different kinds of notations, but you have to just keep in your mind that it is nothing but the product of the magnitude of the either charge, whatever is the separation between the 2 charges. Okay, that's it. Again, this dipole moment is a vector quantity because it has directional property. Again, when we are dealing with this, so this quantity, this vector quantity is acting, or it is directed along the axis of the dipole and from negative to positive charge. Okay, so this quantity is directed from negative to positive charge. Keep in mind, whenever we are defining this dipole moment is as a vector quantity, and here whatever will be some unit vector we have to use here, and this unit vector is directed, or this is pointing from negative to positive charge. ठीक है, so ये जो designation है, ये जो notation है, ये ध्यान में रखना है. Okay, so let us calculate the electric field and potential at some point due to a short dipole. So what we will do in our class today, we will calculate what is the electric potential. First we are going to calculate actually the electric field at some general point due to this electric dipole. However, for calculating that, first we have to calculate the electric potential, and then we will use the relation between the 2. That relation, that is electric field intensity is equal to the negative gradient of the potential. So that definition we are going to use to calculate the electric field intensity. So first we are going to calculate how much is the electric potential at some general point due to a short dipole. here this condition of short dipole has to be there. The reason for this is going to be that the point at which we are going to calculate, we are going to determine the electric potential or electric field intensity, that has to be at far away distance, and therefore we will consider that electric dipole is a short dipole, meaning is the point at which we are determining the electric field intensity at some general point, it is that dipole is short dipole, or the distance where we are calculating the electric field intensity is much larger distance than the separation between the two charges. Okay? So that has to be there. So first let us consider an electric dipole which is consisting of two equal and opposite point charges plus q and minus q, which are separated by a small distance 2d as shown in the figure. So figure जो है हम लोग एक कंसीडर करते हैं, और इसकी जो डायपोल मोमेंट है, so product of either charge multiplied by the separation between the two charges. So we are going to consider this dipole which is consisting of two equal and opposite point charges. Let us draw that diagram. So this is the minus q charge, ये minus q charge है. This is plus q charge which are of equal magnitude. They are separated by a small distance. Here this is the center of this dipole. We will determine an electric potential at this field and potential at this point P, which is at a distance r from this center. उस point P का जो distance है जिस पे अपने को electric potential या field जो है अपने को find करना है, it is at a distance r from the center of this dipole. So this r here is much greater than the 2d. ये जो condition है ये हम लोग ensure करेंगे. So this r is much greater than the 2d, that is separation between the two charges. So the condition of this far off point or the short dipole, dipole जो है बहुत छोटा है, ऐसा वो condition अपने को automatically ensure हो जाएगा, right? So let us first calculate the electric potential. So the potential calculation is very simple. At this point P, how much is the electric potential due to plus q charge? So that is very simple. ये point जो है plus q charge से r1 distance पर है. This distance of this plus q charge from this point P, we are denoting is, let us consider, is at a distance r1. So therefore we can calculate the potential at this point P due to this plus q charge, and let us denote it by v1. So this potential is 1 over 4 pi epsilon naught, whatever is the charge and how much is the separation. So right, so this is the potential at this point P due to this charge plus q. Another is the potential at the same point P due to minus q charge. So here the same expression with the 1 over 4 pi epsilon naught, we are going to denote that potential by v2, and here the charge is minus q, so we will be writing here the minus q, right? So that is minus q over r2, so that this expression becomes minus 1 over 4 pi epsilon naught q over r2. ठीक है. Now अब इस point P पे ये total potential कितना रहेगा दोनों की वजह से? So that is definitely it is going to be the sum of these two potentials. These are scalar quantity, so therefore net potential at this point P is, यहाँ पर इस point P पे potential due to this charge as well as this charge is sum of these two potentials. So we are going to write that. So potential, net potential at point P is algebraic sum. So V1 plus V2. Let us substitute that value. So we can write that V1 की value हमने substitute किया. So this is V1 and this is V2, right? So plus करा है अपन ने, but this quantity is minus. So of course this is going to be the minus. So we can write that V at point r theta, V of r is equal to 1 over 4 pi epsilon naught, can be taken common, q1 over r1 minus q over r2. Now this quantity can be this bracket can be solved and we can write. So this this becomes r1 r2 and r1 r2 को divide किया r1 से, so we will get r2. So this is r2 minus r1. So we can write potential at this point P, that is V of r, is equal to Q can be taken common दोनों में से, तो Q over 4 pi epsilon naught R2 minus R1 over R1 R2. So now we will use this value of this R1 R2 कितनी है वो अपन determine करेंगे from the geometry, and R1 R2, because R1 और R2 जो है they are approximately same, so we can use that R1 into R2 is equal to R square. The reason for this is कि R1 R2 they are approximately equal to R, because that the dipole we are considering 2D is much smaller than that R, so that approximation can be considered. So that approximation, let me write. So this is the diagram again. Let us. So what we can do? How much is R1 now? So from this figure, I can complete this triangle. I can draw a perpendicular from this point O on this R1. ठीक है, so this R2. ठीक है, O पॉइंट से परपेंडिकुलर यहाँ पे ड्रॉप किया तो मुझे R2 का वैल्यू आई कैन डिटरमिन, एंड दिस पॉइंट Q पे से इस पे अगर अपन ने यहाँ पे परपेंडिकुलर ड्रॉप किया, सो दिस एंगल इज एक्चुअली थीटा. ठीक है, सो आई कैन राइट व्हाट आई कैन राइट हियर. सो दिस R1 is approximately R minus D cos theta. So I can write this value of R1 in terms of the known quantity. Known quantity क्या है, मुझे R पता है सेंटर से लेकर के यहाँ तक का डिस्टेंस, और this value, ठीक है, यहाँ से यहाँ तक का वैल्यू, यहाँ से मैंने परपेंडिकुलर ड्रॉप किया, so from here to here and from here to here they are the same distance. So how much is this extra distance, right, from center? So I can find that. So R1 is equal to, which is this one, is this complete distance minus this one. Okay, so I can find that R1 is equal to this R minus D cos theta. From here, this quantity, this much actually, this is a right angle triangle. Let me just show you. This is a right angle triangle. So how much is this extra? Okay, so this is the adjacent angle which I am considering is theta. So how much is this much? So we can write that cos theta is equal to adjacent side. Adjacent side कितना है, इसको मान लेते हैं ये x है. So I can write that x divided by hypotenuse. Hypotenuse ये है, यहाँ से यहाँ तक का d है, 2d है, तो यहाँ का d है, तो that is d. So therefore x is equal to d cos theta, है ना. So which I have from here I have drawn perpendicular on here. So यहाँ से लेकर के यहाँ तक R1 is equal to, ये यहाँ तक जो है वो R1 हो गया. ठीक है, but this much is extra in this R. ठीक है, so R is equal to R1 plus this x. R is equal to R1 plus x. So therefore R1 can be found. So that is this is actually the R minus x. ये इधर जाएगा तो माइनस हो जाएगा. ठीक है, so that is we have written. That is how we have written. Similarly, this angle again, because this point is much larger distance. So ये जो angle है वो उसको भी मैं theta consider कर सकता हूँ, because very large distance पर है. The approximation can be done. So again, this is a right angle triangle. Again on the same line, again I can find, यहाँ से perpendicular यहाँ पे मैंने drop कर लिया. ठीक है, तो so ये जो क्वांटिटी है यहाँ से यहाँ तक ये R हो गया, यहाँ से यहाँ तक R हो गया, and this R2 is equal to R plus, let me write it this as a Y. So this is plus Y. So this I had to find how much is this extra. एक्स्ट्रा कितना है, तो अगेन राइट एंगल ट्राइंगल है तो इसमें अगेन हम लोग cos थीटा लगा सकते हैं. cos थीटा यानी एडजेसेंट साइड divided by hypotenuse. So on the same line I can find the value of, so that will be actually this y is going to come d cos theta. You can do that, I hope you can do that, and from there I can write R1 is equal to R minus d cos theta, and R2 is equal to R plus d cos theta. Okay, so here we can substitute these values actually, and again this condition already I have pointed out this r is much that is ये जो dipole के बीच का जो distance है, separation है between the charges, it is much smaller than the distance of the point at which we are calculating the potential, right? So this condition, and therefore what we can write, this is r1 into r2 is equal to, we can write it like this, ठीक है? दोनों का प्रोडक्ट लेंगे तो ये हो जाएगा, लेकिन क्योंकि ये d जो है, ठीक है, ये d जो है ये बहुत ही स्मॉल है, ठीक है, तो वी कैन और ये जो cos थीटा है, क्योंकि मैक्सिमम वैल्यू ऑफ cos थीटा कैन बी एट द मोस्ट 1, so this is this, because this d is very small in comparison to this one, so this again can be neglected, क्योंकि r square जो है उससे भी बड़ा हो जाएगा, and again this maximum value of this cos theta can be 1, and most of the time this is going to be either this is going to be, अगर ये 90 डिग्री पे हमने ले लिया तो आपको this quantity can be 0, for rest of the quantity this is going to be less than 1, so of course this is again square भी करेंगे उसका और कम हो जाएगा, so this is approximately equal to r square, ठीक है? so हम लोग उसको लिख सकते हैं इस तरीके से, so r1 minus r2 is 2d cos theta, and r1 r2 we can write r square, तो यहाँ पर लिख सकते हैं r square, और ये r2 minus r1 की जगह लिख देंगे 2d cos theta, ठीक है? so that can be written, and therefore this expression, ये जो expression है therefore becomes, so v of r is equal to, यहाँ पे कार्टेशियन कोऑर्डिनेट में मैंने लिया हूँ इसलिए x y z लिखते चले जा रहा हूँ मैं इसको, we can write that q over 4 pi epsilon naught, and in place of this I can write 2d cos theta over r square, right? So 2dq, this quantity, this is nothing but the dipole moment. By definition we had defined it, this is nothing but the 2qd or 2d q2d, ठीक है, या 2dq, whatever you call, this is dipole moment, so we can write 1 over 4 pi epsilon naught p cos theta over r square. So we have calculated, this is the potential due to an electric dipole at some general point. We have not specified till what is this position of this point, तो ये general point है, and because this contains theta also, this angular position also, so we can write that as a v of r theta, ठीक है? सेपरेशन भी है और उसका पोजीशन भी क्या है with respect to this point O, that is the center of this dipole, right? How much is the angle it is making? So we can consider the general cases, the perpendicular bisector case, and the axial point cases later on, okay? So this is the potential which we have calculated, so we can easily calculate how much is the potential. Now our job is to discuss this potential, variation of this potential for the perpendicular bisector points, for the general case, and for the axial points. So let us discuss that. Okay, so we can discuss the different cases. Okay, so the potential depends upon the angle theta, that is the angular position of this point P with respect to the center of the dipole. Okay, so we can consider when theta is equal to 90 degree, meaning is this is the perpendicular bisector points. Let me show the diagram. Okay, so this is the dipole we are talking about, and perpendicular bisector points, यानी with theta is equal to 90 degree, इसका मतलब ये हो गया कि ये जो points है, ये points center से perpendicular जा रहा है उसके ऊपर, ठीक है? ये points, we are talking about these points, as well as we can later on we can also have that side. So ये perpendicular हो गया, ये theta is equal to 90 degree हो गया. So we are talking about these points. ये perpendicular bisector points पे potential कितना है? So here cos theta जो होता है cos 90 वो 0 होता है, and therefore we can, that is that v of r theta, इसका expression है 1 over 4 pi epsilon naught, that is sorry p, this is p over r cube, r square, sorry. So this is p cos theta, cos theta है वो जनरल फार्मूला में p cos theta है, p cos theta over r square. Now this theta, cos theta is coming 0, so numerator 0 हो गया, numerator 0 हो गया, multiplied by this term, so this complete term becomes 0. So for perpendicular bisector points, the potential V is 0. All the points, you consider any point here, 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 any points you consider, the potential is going to come 0. The reason for this is, जितना पोटेंशियल इस चार्ज से यहाँ पर रहेगा उतना ही इक्वल इन अपोजिट पोटेंशियल, इसकी वजह से नेगेटिव पोटेंशियल रहेगा, सो दैट सम विल कम 0. If you consider this point, again same kind of things will be there, same kind of things on this line. Now if you consider these points, ठीक है, अगर हम लोग ये वाला पॉइंट्स कंसीडर करें तो अगेन फॉर द सेम रीजन द पोटेंशियल विल बी 0 बिकॉज दे आर सिमेट्रिक. ये परपेंडिकुलर बाइसेक्टर पॉइंट्स है. So these are perpendicular bisector points. So if I consider any points perpendicular bisector points, so due to the same reason here again the potential will be 0. These are called perpendicular bisector points या तो फिर equatorial points कहते हैं इसको. Now second points are the points for which the theta is 0. These are called the axial points. ठीक है. So इसको end on points भी कहते हैं. So for this theta is 0. So for that this is the general expression. थीटा की वैल्यू जो है इसमें 0 रहे, cos 0 is 1 actually. So therefore for that potential is going to be given by 1 over 4 pi epsilon naught p over r square, because क्योंकि cos 1 ये जो cos theta है now it has become 1. So this is the potential is maximum for these points. ठीक है, ये पॉइंट्स पे पोटेंशियल जो है मैक्सिमम रहेगा. This is for the theta is equal to 0, meaning is on this side. ये जो points है on this side, ठीक है, ये सारे points पे you are calculating the potential. So you have to consider the distance from that point. कितने दूरी पर है, accordingly this potential will be there. So theta is equal to for that is 0. This can be another case when theta is equal to 180 degree, meaning is the points which are on these lines opposite to the axial. एक्चुअल पॉइंट ही है ये भी, बट ये 0 के लेफ्ट हैंड साइड में, इधर साइड में है. सो फॉर दैट एंगल विल बी 180 डिग्री. सो फॉर दैट cos 180 is -1. सो ओनली थिंग इज कि दिस इज गोइंग टू कम, द पोटेंशियल इज गोइंग टू बी द नेगेटिव वन. ठीक है, एक्सप्रेशन वही रहेगा बट पॉइंट जो पोटेंशियल है वो नेगेटिव रहेगा. उसको दूसरे वर्ड्स में इसलिए भी इस तरीके से भी कहा जा सकता है कि वी आर कैलकुलेटिंग द पोटेंशियल व्हिच इज क्लोजर टू द नेगेटिव चार्ज. तो वहां पर पोटेंशियल ऑफ कोर्स नेगेटिव आएगा, और जब हम लोग पोटेंशियल पॉजिटिव चार्ज के पास में कैलकुलेट कर रहे हैं ऑन एक्सियल पॉइंट्स, सो यहाँ पर पोटेंशियल जो है वो पॉजिटिव मिलेगा. ठीक है, और सेंटर पे पोटेंशियल 0 यहाँ पर कैलकुलेट करें किसी भी पॉइंट पे परपेंडिकुलर बाइसेक्टर और इक्वेटोरियल पॉइंट्स पे तो वो 0 है. ठीक है, ओके. सो फॉर टुडे ओनली दिस मच. नेक्स्ट टाइम वी विल कैलकुलेट द इलेक्ट्रिक इंटेंसिटी by using this expression only. ये जनरल एक्सप्रेशन अपन ने डिराइव किया है और अपन ने जो बाकी का स्टडी किया है. लेट मी डाउनलोड योर अटेंडेंस बिकॉज आई हैव ओनली हाफ एन आवर टुडे.